Hello, everyone, and welcome to our webinar. We're very excited about this. This is our first webinar with Andover Corporation. And you see the title of our webinar, and it's Andover Corporation and JD Technologies that's bringing this to you. I do want to mention that we're going to be talking about optical filters and the associated coatings that go with the optical filters, and that's what Andover Corp does. And it really is a key element. You have a lot of electronics, a lot of the brain power that's going on, but it's so important and critical to have that filter the light that you need to have filtered. So it's a very key component, and you're in for a treat to learn more about that. I'm John Knott, and I'm with JD Technologies, and we're a field sales company that represents manufacturers. And there you see a couple of key points that our company is all about. We're a sales and a marketing, and we also do business development. We focus on aerospace, military, and defense. And we do consultative selling. So we're talking to our customers and our prospects and really listening to what they're trying to accomplish, and then helping them come up with a solution. So you won't see catalogs in our hands necessarily. It's really all about listening and solving issues and coming up with solutions. Before we get started, I did want to go over a few housekeeping things. One is questions. We encourage questions. No such thing as a bad question. Ask all the questions you want. We have a team of people that are monitoring those from a technical, administrative, logistics standpoint. If your video isn't working, chat us, right? So that's the way that's going to work. It's very private. We'll be answering some of the questions just one-on-one. But for the most part, we're going to note the questions, and then we're going to have a question and answer session at the end of about a 30-minute presentation. You're going to see scheduling a brainstorming session come up often. And when you see that come up, you can exit out, or you can schedule a brainstorming session, what we also refer to as a discovery session. Because I did mention we do a lot of listening with our consultative selling. Well, big part of that is the discovery session. So if you want to schedule one, by all means do that. If it's in your way of seeing the presentation, and there's an example right there, you can just exit out. And then finally, under handouts, we have some interesting and beneficial documents. So you can go to handouts at any time and select whatever you want and download it. All right, so without further ado, I want to introduce you to Mike Tyner, who is the COO, the Chief Operating Officer of Andover Corp. Very humble individual, very intelligent. He doesn't like to go by that title. He likes to refer to himself as a customer advocate who really knows the technology. He knows the facility and manufacturing. So without further ado, I'd like to introduce Mike.
Thank you, John. I'm really happy to be here today to have a chat with you on how to bring your optical filter concept to production. I can start off with a little background on myself. I am currently the Chief Operating Officer here at Andover Corp. I've been with the company nearly 43 years. It's kind of an interesting story, but the company itself has been around since 1976. We are primarily a coating company. We have 15 coating chambers, and one of the things we're going to talk about today is all the support processes and equipment and things that need to be in place to get the best results for your optical filters. Yeah, we'll go to the next slide. So an optical filter, guys, an optical filter can really be anything that changes the intensity of light, the transmission, the reflection, and the absorption. The most common optical filters are interference filters and filter glasses. Optical coating, which is our business, optical coating under vacuum. It's taking reflective layers with different optical indexes and laying them down in different orders to create cavities of light. So different sequences of reflective materials go down and create different cavities of light. It could be bandpass filters, notch filters, neutral density filters, many kind of optical filters. So part of the process in making sure that you get a really good optical filter is to make sure the company that you're dealing with has all the critical process. At Andover Corporation, we made sure it was one of our philosophies right from the beginning. Anything that we made, we wanted to be able to verify. And then as the company developed and got larger, we wanted to take all the critical processes and bring them in-house. So polishing was one of the first critical processes that we brought in-house. We were buying polishing services from other companies. The delivery was always late. The quality was always suspect. So many years ago, we brought the polishing process into Andover Corporation. In a lot of ways, it's the first step of the coating process. You want to make sure that you get a good substrate, a good polish, a good surface. Sorry about that. And everything is prepped to go. And then it also gives you the ability to finish your optic after it's coated. For the coating process itself, preparing the substrate to be coated is really critical. The cleaner you get the surface, the better the integrity of the coating will be. The better surface quality leads to less scatter, really improves your transmission. It really does start with the preparation of the substrate. So normally there's a lot of ways to clean a substrate. High-speed spinners, ultrasonic cleaning are good ways to start. And even in today with all the automation, hand cleaning substrates is still a huge part of the business. And you need really good qualified techs, good trainings, good matrix, good setup areas, good clean rooms. But the substrate preparation is really critical to getting a good optical coating. Coating chambers, again, coating chambers, there's still metallized coatings that require some manual deposition that really is a skill, something that we do here, and we have trained technicians, almost like a little bit of witchcraft where you have to figure out how to apply metallized layers quickly and appropriately. But most of the coating processes are automated now. So we'll talk about this later in our discussion. We have multiple processes and coating technologies to meet your requirement. Fabrication is also critical to get you to your end goals, whether it's precision chamfering or cutting, shaping, all of those things are critical to your final application. Lamination services, assembling parts, assembling prisms, mounting parts is something that's really important. You need the proper alignment tools, training with your technicians. If you're going to produce an optical filter and then you're going to polish it and you're going to coat it, you have to have test and measurement in place. So you need the proper spectrophotometers, interferometry, non-contact measurements, and environmental testing. All of these things are really important and what you should be looking for in your coating company. Substrates, the next slide, these two slides, we're going to talk about the substrates. I would say when you're approaching a coating company, you really have to make sure they can handle the substrate that you're looking for. In our business, it's micro optics where parts are very, very small. And then you can get substrates that are very, very large. So a good opening question when you're looking for a good coating relationship are what's the largest sizes that you could do? So here at Andover Corporation, we can handle a 14-inch substrate, and we're comfortable on certain products down to as small as 1 millimeter squares on our dicing equipment. But it really does depend on what the part is, how it's made, and there's a lot that goes into the size, believe it or not. We're going to talk about that as we go along. The next part of the substrate is really considering it in your application. So I always like to think of when you're putting your optical coating, when you're putting your optical coating requirement together, it's like putting a puzzle together. And it really does start with the substrate. So a good substrate can also help you reduce layers, a properly selected substrate, I should say. So if you need a good imaging surface and you want to keep the cost down, BK7 is a great solution. It polishes up really nice. It has good thermal properties. It just does a nice job optically at a reasonably priced. Fused silica is always great. It's great for radiation testing. It's readily available. But as you really need to know the inputs of what your design is calling for. Sapphire is a great IR material, for instance, because it cuts off in the infrared. So it can save you literally hundreds and hundreds of layers if you can use a sapphire substrate rather than a germanium substrate or a zinc substrate in the infrared. So knowing where your transmission cut-ons and cut-ons off on your materials is really important. Knowing how difficult the material might be to handle or to coat versus something that's easy to handle and coat that has good thermal properties is just really a huge part of it. So we have listed here, these are the materials that we will coat, and there's pluses and minuses to all these coatings. Like I said, some can be cost drivers, some can be real cost savers, but we would need your help and your input and back and forth with our engineers to make the best substrate choice. But it really does start with making a good choice on the proper substrate. So other things to consider, what's the application for your optical filter? What do you want to do? I mean, do you want to image the
Excuse me, Mike. Sorry for interrupting, but we have a lot of good questions that are coming in. So I thought this would be a good time to take a break and just answer a few of them. That way we don't have too many at the end. One of them is concerning substrates. We use so many different substrates. Which are the most popular and why? I'm not sure if there's a real answer to that, but that
no, I think there's a great answer to that. So in the infrared, I would say that silicon and germanium are absolutely the most popular. Zinc sulfide is a really popular material in the infrared because you have transmission in the visible as well as the infrared, so it helps with aligning your optics. Many times with zinc sulfide, the coating doesn't transmit in the visible, so there's engineering issues there that have to be solved. But I would say in the infrared, sapphire, germanium, and silicon are very popular. The calciums and the barium and the magnesium are much less popular substrates. Those seem to be unique applications where the optical index of the substrate is really important in the dispersion is really important for the application. But I would say infused silica is from the UV through the visible is very, very popular also. In-house at Andover Corp, BK7 has always been our go-to substrate for what we would call a quality optic, something that would be image quality. I hope that helps.
Excellent. Another question is our certifications. Aerospace, military defense, AS9100 is a critical certification. Is Andover Corp AS9100 certified, and what are some of the other certifications?
Yeah, we are AS9100 certified, and we are ITAR registered, and we are working on our security clearance, and we're ahead of the curve on that. Not our security clearance, but the cybersecurity clearances. So, and we're well ahead of the curve on that. We have audits on that regularly, and that's going to be something that's going to be critical. You're not going to be able to deal with primes unless you have your cybersecurity in place and you can pass an audit on your handling of sensitive materials.
All right. Excellent. We have folks from California, Connecticut, Florida, and some are asking, Andover, where does that name come from? Is it Andover, Vermont, Andover, Massachusetts, Andover, California, or what is that? Where did the name Andover come from?
Yeah, so I kind of rushed through the origins of Andover Corporation, where this was my first webinar. I think I may have rushed the first slide a little bit, but Andover Corporation was founded in the owner's cellar in Andover, Mass. So we are a garage company in effect. They started with one coating chamber, and they used to wash substrates in their dishwasher upstairs. So the name Andover Corp comes from our owner wanting to have a broad name. He knew it was going to be a coating business, but he thought if he named it Andover Corporation, he could sell whatever he wanted to down the line. That's the story that he used to tell. So part of it is his home, and where the company was founded was in Andover, and then I think he liked the name because it was a broad term. But we started off in Andover, Mass, and we're up here in beautiful Salem, New Hampshire for now with our 44,000 square foot facility and 15 coating chambers, and it's a great area, great place to work.
Excellent. I have a few more, but I'm going to wait until the end. I'm sure there'll be more questions coming. And again, I encourage everyone to ask any questions, and we'll wait to the end, and we'll answer the additional questions. So thank you, Mike.
Welcome, John. All right, so your application for optical filters, again, when you come to us, the more information you can provide, the sooner the better. So when we get our RFQ, usually there'll be a set of questions that'll go out. But knowing how you're using your filter, whether you're going to be imaging with it or just detecting energy, what spectral range you're going to be using at, what type of blocking you need. These are the fundamental things along with the size. So knowing what you want to transmit, what you want to reflect, what you want to absorb, these are all critical parts of the coding process. And then the levels of those specifications will all determine, and they're really all price drivers. So if you're trying to create a narrow band filter, it's going to be more layers. If you're trying to create a filter that has 7 or 8 OD blocking rather than 4 or 5 OD blocking, it's going to be more layers. More layers, generally speaking, is always more cost. So if you can navigate your application to see what you really need for blocking, for transmission, for rejection, and your ranges, and you can define them well, you can really save a lot of money. A lot of times in optical systems, there's optics that are in line that absorb the light. So you may be trying to put a filter in line that you have an optic that's already in the optical path that'll do a lot of the work for you. So understanding your complete system and the optical path and what you're really trying to accomplish is really where you can save some money. The other really important thing is to know your environment. Temperature is really a big one, especially for assembled optics. The thermal properties, how things are going to outgas is really critical. Not all substrates play together well. You need to find good thermal matches when you're creating your optics. Again, if you're in a corrosive environment, if you're in a hostile environment, you really need to build a robust coating, something that's really hard. And and here at Innovaco, we make anything from DLC to hard sputtered magnetron coatings that would stand up to the severest environments. But again, if you don't have a severe environment, there's low cost solutions that can help you out. So environment conditions are really important to getting a great solution and for a cost driver. And then I hit on a little bit your dynamic range. People come in with drawings and say, hey, I got to have 99% and I got to have 7 or 8 OD. You can look at that, and if for instance, if you had an application where you were looking for 99% and you wanted 4 or 5 OD, perhaps getting 90% and deeper blocking would work for you. That again it's almost like a dance between you and the engineers here to understand what area of the spectrum you're working in, how your materials are going to absorb, how they're going to reflect, and how they're going to block. In some cases, in different parts of the spectrum, 99% transmission is no issue at all. When you start rolling down into different sections, lower and higher in wavelengths, especially when you get into the UV, a lot of materials start to absorb. So when you start getting absorption, or you start stacking layers together, you can have some transmission loss. So often you can compensate that transmission loss by increasing the blocking. So developing a solution, and again, all of these kind of, they kind of run into each other, but really the most important part, if you're looking to get, quality optical coating, the better you can define your application to us, the better you can tell us what your cameras are, what your detectors are, really what you're trying to accomplish. And it starts, we go back and forth like a dance to just try to put you in the best position to succeed, save some money, and go from there. But it really is about really good communication. So we'll review your initial request, get our questions out to you as soon as possible. What we like to do here is we kind of triage every opportunity that we get in. We go over all aspects of it, try to get the pertinent questions out as soon as possible, and then start to look for alternatives. Many times, you guys as a consumer will come to us with a substrate in mind, with a design in mind, and things to accomplish. And I think we add a lot of expertise, and any good company should add a lot of expertise to what's the best path to get you to a manufacturable solution, and something that could save you some money. So really, manufacturability is another thing that you really have to consider. And again, there's a lot of good programs out there, and we have them all. And a good coding company will understand what the computer output of a theoretical curve, and then what it's actually going to look like in real life. So we get really good correlation between our theoreticals and our actual results. That's by plugging in the actual files from the results that you get. So you can plug a design into a FilmStar program, say, and come out with 100% transmission and 8 or 9 OD blocking, but it may not be considering the absorption in that area and how some of the reflected layers react together to give you gaps and cavities. So if you characterize your files properly, you can get really good correlation on your theoreticals. So and then finalizing the design. There's always a design review before it goes out. Probably one more pass with the customer, make sure we have everything we need, and then it'll go out to the customer. Important part of that is to follow up with the customer, make sure that once they got the quote, they understood the quote completely, they understood the theoretical data that was with it, and it doesn't end with the quote. It's usually a process, especially for complex applications. And now we get to the sputtering technology. So these are the sputtering technologies that we offer here in Andover Corp. And each sputtering technology has its pluses and minuses. I would say, the most popular sputtering technology out there now is the magnetron sputtering. And we currently have 5 magnetron sputtering chambers. They're extremely stable, low water content, low shift once you make your coating. I would say the only downside of magnetron sputtering is you have to consider your surfaces. If you're looking for a really pristine surface, magnetron sputtering can sometimes add stress to a surface of an optical substrate. There's ways of getting around that. You can have a robust ratio between the size and the thickness. A ratio of the size and the thickness. You can make a robust substrate so the substrate doesn't bend and twist. You can also put compensating layers on the backside. So if your backside was going to be an AR and your front side was a multi-layered dichroic, you can even out the layer count so the substrate doesn't bend and twist. But overall, a very good technology. E-beam is a great technology also. It is really good for laser damage. does not create surface stress like magnetron. But unfortunately, it's a little less accurate, and there is a little bit of shift that goes with e-beam ion assist coatings. So again, it's a balance between what the most important parts of your application are inside. So resistance evaporation is really the older technology. Here at Andover Corp, we've improved on the older technology. These are coatings that usually are assembled and laminated in. The indexes are further apart, so you can actually put less layers down, create low-cost options. You can make ultra narrow bands at probably a tenth of the cost of hard coating. And there's some really good price points. We always try to introduce the resistance evaporation into the formula, depending on some of the things that we talked about, your environment. If you're in a lab environment and not hostile conditions, resistance coatings are very, very good and a very smart choice for affordability. And then over the years, we've taken these technologies and we've used them together. So things that work really well, things that you need together, you can combine these technologies into an assembled optic, polish it, finish it off with an AR, and have some really cool results. One of our case studies is that case. We talk about that. And here we are at our case study. So over the years, we've had some really interesting projects with prime contractors. And this was one of them. So Lockheed Martin came to us years ago, and they were looking for a dual band filter at the YAG laser, 10640, and they wanted the eye-safe laser to also be visible in the same filter. So a dual band filter, so you could look through, line your laser, but you could also send a signal through it too. So one of the design issues was it needed to be a 3-inch diameter, and they only wanted it to be 3 millimeters thick. It needed to have great blocking, and it needed to have great transmission at those two bands. So going back and forth with Lockheed, we came up with a solution. It's actually 4 coated surfaces, 3 or 4 different technologies. It's a substrate. It's an assembly that starts off fairly thick and then is polished down. That takes care of some of the bending and twisting that some of the coatings provide. And in the end, it's a corrected optic with high efficiency AR coatings on it that allows light through at the laser line and the eye-safe laser line. And it's on the tip of a Apache helicopter and has been really successful over the years. But it was a great engineering project that we needed great inputs and outputs from our team. Successful project. Boeing approached us many years ago looking for a solution. Their halogen lights on their landing lights had gotten more powerful and brighter every year, to the point where they started interfering with the defense systems on the actual plane. So Boeing came to us and said, hey, we need to suppress some UV wavelengths, but we also want to attenuate the infrared, but we want to transmit 99% to the visible. But here's the catch: it needs to be on top of the landing light. So anyone who's ever worked with a good size halogen light understands how much heat a large halogen bulb throws. So we had to come up with a substrate that would keep its integrity with all that heat, and we would have to come up with a coating that also could survive that severe heat. So along with the harsh conditions, the challenging optical specification, we were able to work with the Boeing team to come up with a solution. It was actually, on this one too, was actually a mechanical aspect. We built the bezel that it would go onto to be mounted onto the plane. So again, great input. This was an engineering project to start with. It goes to qual and design, and these have been flying successfully on C-17s all over the world for about 10 years now.
Okay, Mike, excellent. We have a number of questions, and I kind of combined some of them, and I think the questions and when you answer them are going to be taking care of the next few slides that we have. So this might be a way to wrap things up. The first question is from some engineers that are involved in autonomous vehicles.
Yep.
And they're asking if we offer light detection and ranging, filters for that, for LiDAR.
We do.
Okay.
Yeah. And we've had several successful projects in that regard. Yep.
All right. Excellent. And then kind of related, can you explain any advanced sensing and imaging solutions that we might have that are more tailored towards the aerospace, military defense market? I think somebody mentioned IR neutral density, something like that. Do we have anything like that going on?
Yeah. So
Tell it on. You can talk about that one.
yeah. So in our so most coatings that you make, you can turn into an imaging optic. So when you're in the sensing world, there's usually a camera involved and you don't want any distortion. So for instance, any coating that we make, we can develop it so it has good imaging aspects. I either coating it on a quality substrate that has good transmitted wavefront, good parallelism, or coating it, assembling it in, and then correcting the optic on our polishing equipment. So sensing equipment, a lot of sensing equipment is detecting emission lines, laser lines. So again, if you needed, an argon laser at 5320 or a laser line at 10640 or a mercury emission at 3650, all of those things can be accomplished. It really depends on you, what you're trying to, what your cameras are trying to sense. But we can turn anything into an imaging optic. Sometimes sensing optics are just triggers, but it really is about isolating the section of the spectrum that's going to help you complete your application. I hope that answers the question.
Excellent. We had a couple of questions come in concerning testing. Specifically, what kind of testing do we do to make sure that the product that's leaving is meeting all requirements? Specifically, somebody mentioned IR coatings. Like, can we provide spectral measured testing and environmental and physical testing?
We can. We do have all of that here. We have Perkinelmers for the infrared that take you from 2 microns to 50 microns. And we do have a thermotron for environmental testing. And we also have a furnace here, which actually helps with some high temperature testing and coating manipulation. But we also have, we have a lot of spectrophotometry and a lot of interferometry here. We have actually designed our own tunable interferometer. It doesn't go into the infrared, it goes into the near infrared, but it does allow us, it's a standard type interferometer, but we have the light go through a spectrophotometer, which tunes the light, so we're able to look at different sections of light rather than your standard 633 interferometries that you usually see. So we have quite a bit of test equipment. That's one of the core philosophies here at Andover. We want to make sure if we make it, we can test it. So in that regard, we've always been 100% test sampling here. So if you ordered 30 or 40 parts from us and you wanted to see data on every single part, even if they're made in the same lot, we generally check every single part, and we'll do interferometry and the spectral qualities on 100%. And then also as well as 100% physical measurements and inspection at the end.
Excellent.
One of the other things, Sean, I didn't mention is we do have a master machinist here on site too. So holders, internal repairs, things like that, prototyping can be done really quickly. And I think, again, if you're looking for an optical shop, having machining on site, as well as the fabrication and the polishing, the measuring is also critical.
Mhm. Excellent. All right, the last question, and I'm going offline with some of the other questions, and we'll start discussions offline with companies because a lot of times we get into confidentiality and have to
Yeah.
execute NDAs, which we're very used to doing. But the last one that a couple folks asked, and it's a good one, is talk about optical assemblies and
Yep.
what we're doing in that area, because some of the companies are want a company that does more than just the filter or more than just the coating, but more of an optical assembly. So if you could talk a little bit about that, I think that's a good way to wrap things up here.
Okay, so we've been doing simple optical assembly for many years. Plano assembly, where actually our resistance coatings are usually coated on one plate and then coated on another, and those are assembled together. But we develop good techniques on those to press out the epoxy, assemble it properly so you get a nice even epoxy layer. So that's probably the most simple assemblies that we do. We also do image quality assemblies, again, where you're looking for a really thin layer epoxy, also Plano. But we've developed good techniques for prism assembly. So the type of assemblies that we do here are mainly prisms. So we do Plano assemblies, and we can do doublets, but we do a lot of Plano assembly, and then we do prisms, prism assembly. So we have the proper tooling, most of it made in-house, and then we have the proper instruments to measure once the optic is assembled. So we do a lot of our alignment on our prisms right on our interferometry equipment. You can do it in reflection and transmission. Make sure you have the right number of lines and fringes to make sure that your optic is actually really flat and aligned properly. So we have alignment equipment and assemblies. Again, that's a technique that you need trained technicians and people with a lot of experience and good technique, and just a good morale and good attitude by everybody.
Excellent. Well, all right. Well, thank you very much. I think we can end things here. We've gone over a little bit, but it was because of the questions, and I want to respect everybody's time. I know it's a busy time of year, and you're probably going to be going out for lunch and doing some Christmas shopping. But thank you very much for your attendance. Mike, thank you for the presentation. Very, very good. Everyone is going to get a copy of the presentation. It's all in the public domain, and you're also going to get a copy of this webinar. So feel free to distribute it to colleagues, friends, relatives. Makes great Christmas gift. But thank you very much for your interest. Thank you for your attendance, and we'll definitely be in touch. Merry Christmas and Happy New Year, everyone.